Okay, hello everyone. My name is Ehsan. I'm a PhD student at Politecnico di Milano, and I'm hosted by Aramis company as part of a Gradient project. So my PhD topic is about improving the reliability of a power grid system by predicting the remaining useful life of components which equip with prognostic and health management capabilities. So for my first year of a PhD, I work on data-driven prognostic approach. So now I'm working on the physics-based prognostic approach, which in this methods, we need a degradation model because there are many components in the system, and we want to know when exactly the components are going to be failed. And before this situation, remove or replace the components from the system. So now I'm working on physics-based prognostic algorithms. We need a degradation or a damage model of the components, and also we need the measurement data which we capture from the health monitoring signals. And there are some parameters in the degradation or damage model that we want to estimate to help us to predict the remaining useful life of the system. So for the model parameter estimation, I'm using the particle filtering, which is a sampling-based approach based on Bayesian inference. This is a basic picture of crack growth that I'm using for the physical model. So we want to remove the components exactly before this failure condition. So we need the degradation. We need the measurement data that we capture from health monitoring signals, and we predict the distribution degradation of the model. And in the current cycle, we can predict the remaining useful life. So, for example, here you can see some result of my crack growth model that we predict the parameters, the parameter model and the remaining useful life. And also the other thing that I'm working on it is related to the power grid system. We want to know what is the best time to remove the components from the system, because in the power grids, this removing and replacing is important, because if we cannot remove in the best time and the failure happens, it leads to the blackouts. So it's so important for this. We need to know the component stop criteria, and based on some metrics and some methods, we can find the best time of removing the components, and we can calculate the transition kernel from working to fail conditions, and calculate the unreliability of the components, which show the probability of failure of the components over time. So now, for the next step, I want to integrate the physical model and data-driven model as a gray box model to improve the reliability of the power grid system. Thank you.